It's a resolutions, right? Resolutions. So what is the mean about the resolution or the component of force? Yes, what's that? What are the components? Resolutions. Right? Okay. What do you think? Like we have a force, then we know to get the components, right? Horizontal line, but right? What are the components? Right? Right? F cos theta, F sin. Right? Components. Yes. Right? Right? එතකොට මොකද වෙන්නේ බලමු. right? එතකොට අපි හරියන්නේ right මතක තියාගන්න පොඩ්ඩක් right? එතකොට end එක එකම right හරි බලමු. A separation of a single force acting on a particle into two or more forces, right? In such a way that the effect of the single force on the particle is the same as the effect on it by the separated forces. Okay, right? But it's a what? It's a converse of resultant. Then we have two forces or more than two forces. What happened? We can count one of them, right? Given the same thing, it's we call the result. Now we have one thing, then we can get two or more ones, right? Then they are given the same thing. Then what happens? That more things we call the separation or the resolution. Okay, right? That's the way of right. We get the resolution. Right, but mathematically we can get right easily right that to right in a perpendicular direction, right? That's the thing is there. Okay, then what happened? Right, the reverse of the right or the converse of the resultant, we use the get the resolutions. Okay, that means what? If we have a one force, then we have how many resolutions there? How many components? Only two. Only two components we can find. Okay. Only two? No. Right? We can get many more. But easily we can't get. Then we need to draw accurately, right? And need to measure it. Then we can see what happens. Okay. But mathematically, easily we can't get. Okay, that's a right reason there. Okay, otherwise what happens? Right? If we have both, then we can get many more resolution parts. Infinite of resolution parts. Okay, then, right? Okay. Right? Is known as the resolution of the single force into separated right forces. Each force obtained by resolving the force is called the component or the result part of the original force. According to the parallelogram law of forces, if two forces are represented in magnitude and direction by the two adjacent sides of a parallelogram, the resultant of two forces will be represented in the magnitude and direction by the diagonal to the point where the two forces meet. Hence, if the finding two forces equivalent to given force parallelogram should be drawn with the line segment representing the given force as a diagonal. Okay, now what happened? Now we have a force F. Right? Earlier we draw the parallelogram to get that, but now we can draw right any parallelogram. Right? That given force be a what? That given force be a diagonal. Right? Then these forces we call the components. Right? Then how many right parallelograms we can draw there? One of that? Only one? No. Right? Because why? Now these two F1 and F2 and we can draw right another one like that. Okay, so it's PF3 and right F4. Okay, then what happened? We can do another one. Okay, so okay, right now whatever we can get any number of right parallel nodes like this, then they are right they are components of right that F. Okay, right, then you can draw it. So we can do it.